than what we've been doing, because law of sines and law of cosines, that sure sounds like trig, and I just said that second semester doesn't have much trig to it, and it's just that you don't really need to know much trig to be able to do law of sines and law of cosines. So we had SOHCAHTOA last semester that helped us find side lengths or angles, but the catch was it had to be a right triangle. Law of sines and law of cosines are going to be formulas that help us solve oblique triangles. Oblique triangles are triangles that do not have a right angle. So this also works for right triangles, but we have other stuff to know how to do right triangles. So this is the formula for law of sines, here or here. They both say the same thing. They just take the reciprocal of these and you can get these. I tend to use this one if I'm trying to find a side length, just because the side lengths are in the numerator already. Remember, lowercase a, b, and c represent lengths, and capital A, capital B, capital C represent angle measures. So I tend to write it this way if I'm finding an angle measure, but honestly doesn't even matter. I will also add that since we only spend a few classes on this, we do not make you memorize these. I will put these on the quiz when we get to it. It's very easy to memorize, but again, the purpose of this is to help you if you see them on the ACT, and on the ACT the way they write it, you don't really need to have the formulas memorized, so at least the way we've seen it. So when can you use law of sines? So you don't have to memorize this, but you do need to memorize that. You can use law of sines if you have any two angles and one side length, and we will ask you that. And sometimes we refer to this as angle, angle, side, or angle, side, angle. Both of those have two angles and a side. And then the other time you can use law of sines is when you have two side lengths and the angle opposite one of them. This is referred to as side-side angle. Now, I could probably go on and on about this for a day or two, but hopefully these sound a little familiar to you from geometry. So in geometry, you use these to prove that triangles are congruent or similar. So these two you probably have heard of before. You probably didn't hear of side-side angle in geometry because it doesn't prove that the triangles are unique. So we need to put a star by this one. This one is only sometimes works. This is actually referred, side-side angle is referred to the ambiguous case, and on our agenda that I'll put back up here in a bit, there is a video if you'd like to watch how to do the ambiguous case. It sounds pretty complicated and it's a little bit long-winded, but we will put like one bonus question on the quiz. So if you're interested in learning about the ambiguous case, it's just that depending on your side lengths and your angle, you could have no triangles, two triangles, or one triangle. So it's kind of complicated. But in a college trig course, they will make you learn that, but it doesn't show up on ACT. And since that's why we're doing this, we're not making you do this. Okay, but it's very easy to use. So if you've got two angles and a side, here's an example that's already been typed up. Notice they plugged the stuff into the formula. They plugged in the three numbers that they had, and then they went about solving for the one that they wanted. So they put sine of 48 degrees and 10 as a ratio because they're opposite each other. And they put sine of 55 and x together as a ratio because they're opposite each other. And that's using the formula. Looks like they cross multiplied to get rid of fractions, and then undid times with divide, and then to get from here to here they just used their calculator. So if you have any two angles on one side, you get to just plug in the numbers into your formula that looks like this and then cross multiply. Now if you're solving for an angle, so formula is not much different, but again I already typed it up for you just so we can move on a little bit faster here. Notice I did the sine of x over 12, they're across from each other as a ratio. Sine of 42 over 22 as a ratio because they're across from each other. And then if you start going about solving this, they undid times 12 with divide 12, and then they got down to here. They got sine x is equal to this. Now, remember, sine x is not the same thing as angle x. Sine is always between -1 and 1, so this is always going to be a small number, but this is not the angle. So right here, you probably want to put a star in your notes because you'll have to do this for angles. You'll want your calculator to be in degree mode because we're going to want a degree. And to go from sine x equals to just x equals, you have to do inverse sine of that. That way you're asking your calculator what angle has a sine of that, and then it will handle it from there. Now, of course, you need to practice this a few times, but that's really all law sines is. If you have the right information, plug it in, you're going to have 3 or 4 things, solve for the last thing. If you're solving for a side length, it worked out like the example on the left. If you're solving for an angle, it worked out like it did on the right, and you just need to make sure that you know how to go from sine x equals to x equals. Honestly, just a couple of those and you'll realize that they're pretty easy to deal with. Okay, moving on, we've also got the law of cosines. So again, we will not make you memorize the law of cosines, but this is all 6 different ways it could be written. And it has the same purpose. It's to find a side length or a missing angle of a triangle that's not necessarily a right triangle. Doesn't have to be a right triangle. The one that I kind of like to point out is this one. Now, I don't know, 4 or 5 years ago we did used to make students memorize these before we just decided it wasn't important. But if you look at the first part of this, it's really just Pythagorean theorem. A squared plus b squared equals c squared. But Pythagorean theorem only works when it's a right triangle. If you tack on this minus 2ab cosine c, cosine because it's law of cosines, then you've got a formula that's just about ready to solve for c. Of course, you'd need to take the square root of both sides, but if you have AB and angle C, then that's ready to go. If you were trying to find side A or side B, then what you're plugging in is a little bit different, but it follows a very similar format. You could solve these and rearrange them for cosine A, cosine B, or cosine C, but we will do that for you. So notice, if I was trying to use one of these formulas over here, so again, you don't have to memorize these, but you do have to know when to use them. We will ask you that. For these, if I'm trying to solve for A, B, or C, I need to know 2 other lengths, BC, BC. So 2 side lengths and their included angle. Included means the angle that's trapped in between them. So the shorthand way of saying that is side angle side. Side angle is not considered that because the angle is not in between the sides. It's got to be trapped in between it to be included. Okay, or if you're trying to find an angle, look at what this is where I feel like you don't really need to memorize these, at least in my opinion, because you just look at the formulas and see what you need. If I'm trying to solve for angle A, angle B, or angle C, I need to know side A, side B, side C, side A again, or B again, or C again. But you need to have all 3 side lengths if you want to use it to find an angle. Okay, and then that's the only two times you could use law of cosine. Side angle side, or side side side. So below, I've got a couple of examples already typed out. Again, you'll practice this from a few texts. The book assignment's really not that long, but you'll try it here in a few minutes. But here's somebody that is, notice that they had side, angle, side. So they said, here's the formula for law of cosines. They called this side A, looks like, plugged in 10 for A. Called this side B, plugged in 10 for B. Plugged in 10 for A again, plugged in 9 for B again, just like the formula says. And then this would make this angle C. So they plugged in 47 degrees for angle C. And then they had a formula. And to be honest, since you're going to need a calculator anyway, what I would probably do is I wouldn't do none of this. I would just go straight to my calculator and have it say, if x squared is all of this, then x is the square root of all of that. And again, you would need to make sure your calculator is in degree mode, but otherwise, throw it in there, hit enter, and you are done. So since you don't have to memorize the formula, you just have to know what you're doing by plugging those numbers in. It's pretty easy to do. Okay, and then on the right, an example of someone using the law of cosines to find a couple of the angles here. So they gave us 3 side lengths, which is when you can use the law of cosines to find an angle. So notice they said here's a formula to find it, or here's a formula to find it. They plugged in the numbers as each formula said. I'm assuming that they hit enter on their calculator there, got a really small number, because the cosine of an angle can only be between -1 and 1, as we talked about last semester. Again, you don't really have to know why anymore, but I guess it's helpful. But it's important to keep in mind, that's not how big the angle is, that's what the cosine of the angle is. So just like with sine, you have to do inverse cosine of that to get the actual angle. And then what about if I wanted to find the last angle? Could I use law of cosines for that too? Law of cosines work on all the angles? Right. But, of course, if you have 2 of 3 angles, you know, if you're in a time crunch, you probably just subtract them from 180, just like you've been doing. But you could always do it as a backup. So again, you got to practice plugging those numbers in, making sure you know how to use your calculator. But because we are not making you do the ambiguous case, which only goes with law of sines, you know, the formulas will they will work. If you're trying to use it when you're not supposed to, then you're not going to have enough information. But short of that, that's all it is. Yeah.
So anytime you're finding an angle, you're going to have to take the inverse of them?
Correct. Yeah. Because remember, if you're using a regular trig function, remember the input was an angle and the output was a ratio, right? When we're doing this, over here, these are the ratios, but we're interested in the angle. So if we plug that mess in, when we switch that, if we plug in the ratio, then the output of that would be the angle, which is what we really want. Okay. Anything that jumps out before we practice some of law of sines, law of cosines? Okay, to finish up the notes though, we do also throw 2 new area formulas at you. So when you have side angle side or side side side, these are ways to find areas of a triangle. And I'm not going to go through the proof of this too much, but I guess I'll do it just enough for you to see it. So right now you should know that if you want the area of a triangle, probably the only one you've ever heard is 1/2 base times height, and that's still true. But now that you have a little bit of trig under your belt, we have a way to figure out what this height would be. So, normally, you don't have to go through all this, but I want you to see where it comes from. If I was looking from angle A, and I did a sine ratio, sine of angle A, that would be opposite, which would be H, over hypotenuse, which would be side B. So in that case, the height is B times the sine of A. So instead of saying 1/2 base times height, I could say 1/2 base. Oh, well, that's the one I got. Yeah, I've already got it. Oh, well, I'm sorry, what would my base be in this? Which one of these sides would you call the base? All right, probably C. Most times we just call the one on the bottom the base. So base would be C, and height would be B times the sine of A. But I'm going to rearrange these two. And I'm going to highlight it. So a fancy way to say height is B times the sine of A. And all I really did was say, wait, there's a right triangle over there on the left. Let me do a SOHCAHTOA equation. But you could also do 1/2. Let's see, we've got BC sine of A. So we could have AC sine of B. Or the last possibility would be AC sine of C. Oh no, that's not right. I've got C both times, AB. AB sine of C. So anytime you have two side lengths, all we're really doing here is to get the other ones, and again, I'm just sparing you, but instead of putting them in this order, I might put them in this order. So now the base is B, and the height formula looks a little bit different. But if you've got two side lengths, and the included angle, 1/2 times the two side lengths you have times the sine of the angle in between is a quick and easy way to find area. By the way, I have also seen this on the ACT. Not nearly as common as law of sines, law of cosines, but easy questions if you were familiar with that formula. All right, and then finally, my favorite, just because this one's super common in higher mathematics, this is called Heron's formula. And if you know all three side lengths of three side lengths of any triangle, you can find the area with one formula that says take the square root of S times S minus one of the lengths times S minus the second length times S minus the third length. And then your question should be, well, what is S? So S is when you add up all three lengths and divide by, what would you guess you would divide by?
3.
Okay, so put a 3, but put an X through it. It's not an average. Everyone would guess 3 because it would be an average. It's 2 because this is called the S is for semi-perimeter. Just like a semicircle is half of a circle, semi-perimeter is half the perimeter. So again, same thing, you don't have to memorize these formulas for us. You just have to know that they exist. And for us, if we want you to use this one, we're going to have to give you two side lengths and the angles in between them. So you're literally going to get to go to your calculator and do 1/2 times one side length times another side length times the sine of the angle in between them. And if your calculator's in degree mode, you are done and you have the correct answer. If we give you all three side lengths, you're going to have to do this to figure out what S is, and then you're going to plug that in here, 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 and here. And as long as you're careful that you throw it in the calculator correctly, what it tells you will be the area of the triangle. So I'm assuming none of you guys have ever seen this one before. I've always wondered why they don't show that in geometry, just because it's so easy to use and so helpful. But anyway.